everyone. In the previous video we have completed the predictive analytics, that is overview of supervised learning, linear regression models and least squares. Okay, in this video we are going to learn about what is multiple regression. See one thing, in linear regression I have told that we have only one independent variable and one dependent variable, whereas in multiple regression the name itself is saying that multiple means two or more independent variables. Okay, multiple regression is used to estimate the relationship between two or more independent variables and one dependent variable. Why we are using this multiple regression? To find the relationship between, or to estimate the relationship between two or more independent variables and one dependent variable. Okay, so where we are using this multiple linear regression? Let's see. We can use multiple linear regression when you want to know how strong the relationship is between two or more independent variables and one dependent variable. So we are testing whether the relationship is strong or weak between the two or more independent variables and one dependent variable. How? Let's see this example. How rainfall, temperature and amount of fertilizer added affect crop growth. See, here we are having a crop, and in that crop growth we are seeing that how rainfall, temperature and amount of fertilizer added affect crop growth. Means that how these all rainfall, temperature and amount of fertilizer, these three are independent variables. Remember that rainfall, temperature and amount of fertilizer is independent variable, and crop growth is dependent variable. This crop growth is dependent on which independent variable? It is dependent on rainfall, temperature and amount of fertilizer. If three independent variables are performing their actions according to the crop growth, then the crop growth will be good. If it is any three of them, if any three of the independent variables, that is rainfall, temperature and amount of fertilizer, is doing anything effect to the crop, then the crop growth will be decreasing. So where is the relationship between these two? Here the crop growth is related to rainfall, temperature and amount of fertilizer. Okay, so here we have three independent variables and one dependent variable. Then how to perform a multiple linear regression? Then how to perform that? The general form, the equation for linear regression. See, in generally we have linear regression, I have told before. So for that linear regression we have general form of the equation, that is y is equals to b into x plus a. Okay, here y is the dependent variable and x is the independent variable, whereas a and b are coefficients. Okay, so this is the general form of linear equation. Okay, now let's see the equation for multiple regression. Okay, in the previous one we have seen about the linear regression, that is y is equals to b into x plus a. Okay, for the equation for multiple regression looks like y is equals to b of 1 into x into 1 x of 1 plus b of 2 into x of 2 plus so on b of n into x of n plus a. Okay, in that linear regression we have only one in the sense, that is we have only one independent variable and one dependent variable, where in linear regression. But in multiple regression we have more than one independent variable, so we uses that b of 1 into x of 1. We are using multiple, so that's why we are using this equation. Okay, here x of 1 and x of 2 is what? Value of the first independent variable and value of the second independent variable, whereas b of 1, b of 2, these all are what? These all are coefficients. Okay, next, now see an example. Imagine that you are a traffic planner in your city and need to estimate the average commute time of drivers going from east side of the city to the west. See, you are a traffic planner and you have to estimate the average compute time of drivers. Means you have to estimate the drivers time from where to where, from going to east side of the city to the west side. In a minute or in a seconds or in a hour, you have to calculate or you have to estimate the driver's time from going from east to the west side of the city. Okay, You don't know how long it's take an average, but you do know that will depend on a number of factors like distance driven and the number of stoplights on the route and the number of other cars on the road. See, to perform any action or to perform any to estimate any time, we need two factors, that is one independent variable and one dependent variable is must and should. But in linear regression, we use only one and one independent variable and one dependent variable. Whereas in multiple regression, we use one or more independent variables and one dependent variable. Here, what is the dependent variable? Here, the dependent variable is the traffic planner. The traffic planner is the dependent variable. What are the independent variables here? We have three independent variables, that is distance driven and number of spotlights and the route and the other cars. Okay, these three are the independent variables. In that case, you would create a linear multiple regression equation. Okay, in this case you should create a multiple linear regression formula. For that equation, how we can write y is equals to b of 1 into distance. We have three factors, right? Distance plus b of 2 into spotlights plus b of 3 into cars plus a and b are coefficients. Okay, here y is the average commute time. We are finding average commute time. Okay, distance, what is the distance here? Is the distance between the starting and ending destinations. Stoplights, number of stoplights on the route. Okay, you should calculate these all things to estimate the distance of the drivers from east to the west in the average compute time. Okay, to estimate average compute time, we need all these factors, remember. Okay, here a is constant, representing other time consumers, that is putting on your seat belts, starting the car, maybe stopping at a coffee shop. This all we are told that a and b are constants, so this will show rest of the things what the driver is doing before starting the car. Okay, and next, this is one topic. This is the main overview of a multiple regression. Okay, you can write that equation and this example. Okay, now we'll see multiple outputs. For this multiple regressions, we'll get a multiple outputs. Okay, so how these multiple outputs will work? Multiple outputs refers to the situations where you are trying to predict more than one target variable. Means we are having two targets to complete, then we will get the multiple outputs. Here in the previous example, traffic planner is there. There is only one traffic planner. If there is a three or more traffic planners there, we'll get a multiple outputs from the multiple cities, right? So to get that, we'll use these multiple outputs. Okay, here are few common scenarios where multiple output might be relevant. See one thing, in the city, in both cities, we have both traffic planners. Some people may get into the east to west side within a 1 minute or within a 1 hour. So the average answers between these two areas will be same. Okay, so at that case, we are saying that we get the relevant answers for two or more variables also. Okay, see how it will be. Multivariate regression. In the multiple outputs, we have this type of regressions. Okay, multivariate regression. What will happen in this multivariate regression? Predicting both house price and the number of bedrooms based on the various features like square footage, location, etc. Here we are finding the price of the house. Price of the house based on what? Features like square footage, locations, etc. We are predicting not only a single house, we are predicting both the houses. It means we are having multiple outputs and we can get the at least relevant answers like same size or in the same location side by side. So these are all the multiple outputs relevant. Okay, so in this case we will get some outputs. Next, multi-label classification. Multivariate, here we have multivariate regression. Okay, here we are having multi-label classification. And what in multi-label classification, what will happen? First, see example. Okay, classifying images where an object can belong to multiple classes simultaneously. For instance, a picture of a beach might be labeled as sea, sun and sand. Here is a task for you. You have two images belongs to the same beach. Okay, and you have to calculate the sunset or sunrise time for the both beaches. Okay, then what you'll do, you'll find both the relevant answers from the two, right? We'll get multiple outputs. Means if you are seeing one side of the beach, you'll get one output. If you are seeing another side of the beach, you'll get one output. Same in the case for recognizing the images or where an object belongs to the multiple classes. This time we'll get multi-label classification. For classifying the images, we'll use multi-label classification. Whereas to find the multiple outputs, we'll use multivariate regression. In that regression, we are finding the two houses price. Okay, here in multi-label classification, we are finding the pictures or images where an object can belong to multiple classes. Okay, next, the third one is time series forecasting with multiple time series. Then what is this time series forecasting? In that previous multiple regression, multivariate regression, and this multi-label classification showing that one is the cost of the price of the two houses, and this one is showing the images relevant answers. Then what is time series forecasting? Predicting sales for multiple products or stocks simultaneously. That is, we are predicting in the sense we are estimating the value of future. Okay, predicting means estimating the value of future. Okay, when dealing with multiple outputs, the choice of the model depends on the nature of the problem. Means when we are solving a multiple outputs, when we are dealing with the multiple outputs, the choice of the model depends on the nature of the problem. It depends on the nature of the problem. Okay, what is the nature of that particular problem? It depends. Okay, to how we can find that particular natures of the problem, we have some few approaches here. First one is multi-output regression models. What will be this doing? Extension of traditional regression models to handle outputs. This model will help to handle the traditional regression models to handle outputs. Okay. Next one is multi-output classification models. In this, what we are doing? Extension of classification models for multiple labels or categories. Okay. And this is the formula for multi-output regression. Okay. Predicting two or more numerical outputs from the given input. We'll use this. Okay. yi is equals to b0 plus b1 x1 plus b2 x2 plus so on plus bk xk plus ei. Here ei is the random error. We'll get some errors when we are considering both the places or both the multivariables. Okay. And here y is the dependent variable. Why I am saying that y is the dependent variable? Because we are finding the dependent variable based on all the independent variables. Here both independent and dependent variable connection is called as multiple regression. We are estimating the relationship, how strong it is. Okay. So for finding the y, we need exactly the x values also. X values are the independent variables, whereas y is the dependent variable. This y dependent variable is dependent on the x independent variables. Understood that? Okay. If you understand this logic, you can write it. Okay. Here b0 is a y intercept and ei is the random errors. If we get some errors, we'll put at the last, that is ei. Okay. This is the formula of multiple outputs, and these are the types. Okay, multiple regression types, multiple label classification. Okay, multiple outputs topic, and we have completed the multiple regression. Okay, thank you.